What is up, everybody? Welcome back to another episode of Large Data Bank. Hope you guys are having a great day so far, a great week, and I hope that you're going to enjoy today's live stream. We're back with the old synthwave DMCA free music. MD Layer, thank you so much for that 16 months. Goodness gracious. Goodness gracious. You guys rock. You guys all rock. Matt, you double rock for being a 16th month subscriber. That's a lot of months, to be honest. Time really flies when you stream once a week. JB Pratt, it's nice to see you. Hydron, Chronic the Nikon. Hello. Nikon, how's it going? You missed my mustache. Mustache is dead, dude. It's dead. It's done. The girlfriend nixed it. No, just kidding. I also thought it looked kind of bad. Here's how I thought about the mustache. I liked wearing it, but I did think that it was bad. You know what I mean? You ever like something, but also know that it's wrong? That's how I felt about the mustache, more or less. What's up, Rail? Friday turned into the day you tell me about your CRDB adventures. Yeah. Well, I always enjoy hearing about them. So let me know. I see that Vinet says wrong. I think that you've had some good interactions with somebody on the issue you filed. So thank you again for filing that issue. I hope. Seems like you guys are onto something. Find something wrong. It's always a good thing. You soft lock the database. That's the dream, right? That's not the dream. That's the opposite of the dream. But hey. Yeah, hope you guys can get to the bottom of that soon. Anyway, you know, it's been a good week. This is the last week of roofers. I think I complained to you guys about the roofers last week, and it was a 2-week project. Turns out it wasn't a 1-week project. There was the roofers, then there was the hurricane, which conveniently happened in the middle of the roofing. That's always the dream. Speaking of the dream, you want to do your roofing project while there's a hurricane. That's just, that's going to stress test your roof. And I can, happy to report that the in-progress roof successfully managed to stave off the water from that hurricane, and there was no leak. So how about that? That bathroom leak, it's gonzo. It's gonzo. It's done. We're done with that bathroom leak. The roofers just finished today. They drove their car off. I mean, let me tell you, it was annoying. A lot of banging, pounding, drilling, ripping, adhering. There's a lot of verbs that you do when you're a roofer. And gosh, I really feel bad for those folks who had to do the work because it was hot this week. Oh my goodness gracious, like 95 degrees, and to do it in full sun because, of course, on the top of the roof, there's no trees, right? But, they got paid. So I hope that was good. And the point is that the roof is now done. So I'm pretty pleased about that. I bet my landlord is going to be pleased about it too. Project's over. The cherry picker's gone. I can wake up. There aren't going to be men that could be looking into my window from the roof. I feel like that's been my routine. Get up a little early, try to leave my bedroom before the roofers come and see my sleeping body in the bed through my flimsy curtains. So that's been what's up for me. In my personal world, had a house guest last weekend. That was pretty fun. You guys ever have a house guest? I bet you do. It's pretty nice. I feel like it's kind of a thing that doesn't happen so much post-COVID, but look, we had one. It was nice. They stayed in this room, in fact. That couch back there, it turns into a bed. So I was locked out of my my kingdom, this computer kingdom, but I think that's a good thing, right? Get locked out of the computer kingdom for a weekend, do other things, hang out, talk to people, get out of the digital space and into the real life space. You know what I mean? Lieutenant Junior Plitskin, what is up? What is up, Pratik, as well? So, what else? Anything else? What else is going on? I don't know. I feel like that's kind of the main things. Yo, Void Rose, what's up? Welcome in, everybody. What's happening with you guys? Any fun things in life? unfun things, medium fun things, anything of that nature at all? Yeah. Work stuff, huh? New fun task. That's good. Fun is always good. You can have a work thing that's a fun thing. That's a good thing. Docker rabbit hole. What is up, low bar? Told your manager that you're burnt out. He told me he wanted you to stay, so it could take a month off. Dude, hell yes. A month off? Where are you going to go? That's the best. I think a month off is really what you want out of life. You can travel. You can stay put. You can do anything else. Been stuck with Linux audit, misbehaving and destroying VMs on Azure. That sounds brutal. Linux audit? Is that like a security tool? Banana Pooper's been pooping bananas. Nice, nice. That's pretty cool. Pretty cool from Banana Pooper. Need to learn how to drive? Figure out plans. In between switching jobs, have a 10 days break. Yeah, maybe people... Is this like a transitionary period for people? Is there something in the air, you know? People are doing their transitions right now. I feel like some people are coming back from vacation. Some people are going. Maybe it's that midsummer, you know, it's like extremely hot out. People are ready for autumn, feeling like they need something new. I kind of get that. 5 coworkers leave in the past 4 months. Ouch. That'll hurt the morale. That'll make you feel burnt out. Once you have a team and people start leaving, that's always a sad thing. That's always a sad thing. What is up, cheese lover? Linux audit is the default framework for auditing everything on Linux, and it's expensive. People don't always understand security isn't always free. Yeah, I mean, security... I feel like security is often not free, right? Like, that's one of those things that people would prefer to pay for versus not, right? Because it's like, you don't know what you don't know, right? You're a small company and you don't have a big security team, and that's the moment in which you should be paying, right? When you don't have those in-house people, you're like, ah, God, gotta buy some tools, help me. Dat Boy, welcome to Dat Boy. Where's your unicycle? Thinking about applying for a new job, don't feel like going through the interviews. Yeah, that interview stuff, man, it's brutal. It's hard to avoid that these days, I feel like. Security costs performance and usability. I see what you mean. Yes, that is also very true. Yeah, it's a cost, man. I feel like people are coming more and more around to the fact that it's one of those costs that you should be building into your plan, you know, early on, because it's inevitable, important, and a requirement, right? It's not like something that you can patch on later. It's got to be there from the very beginning. So, well, that's cool, guys. Thanks for telling me about your lives. Audit everything but want full performance. Yeah, exactly. That's tough. That's tough. They want everything. They want everything. People always want everything, right? You can ask them for more hardware. You can be like, well, if you want all the audits and you want the full performance, you're going to need to give me double the hardware. Something like that, right? It's my pleasure to do the stream. Oh yeah, my Go Time episode got released. That's another thing that happened. So I think I mentioned a couple weeks ago I did this Go Time episode. It's a podcast with Brian Borum on memory management stuff. So that got released. You should give it a listen. It's on my Twitter. I hope you enjoy it. I haven't actually listened through it because it's scary to listen to yourself talk, but give it a listen. I hope it's good. And if you guys have questions on it, let me know. Hit me up on the Twitter. Okay, so let's get into it, shall we? Let's get into it. What are we doing today? Oh, you love Go Time? Listen while you're at the gym? Ah, thanks, Rail. Let us get into it. So what are we doing today, you guys? I want to do a couple of things. One is that I want to fix the tests from the PR that we did last time, just to get back into this swing of things. You know what I mean? So if you guys remember last time, we were working on this improved distribution policy for index joiners that allowed you to spread out the join processors onto the nodes, onto all of the possible nodes that the right-hand side of the join could live on. Whereas before, it only really let you put join readers, these like lookup join kind of nested loop join processors, basically, on the nodes on which the left-hand side of the join was living, right? And for various reasons, that can be inefficient. So we worked on placing them where the data could live that is on the right-hand side of the join. The only problem with this is that, well, it's not the only problem, but one big problem is that if you have a big cluster and a big right-hand side table, which is common when you do nested loop joins, then you're gonna often plan a ton of right-hand side join processors. Let's say you have 128 node cluster, and you're doing a lookup join into some massive table that has some data on every single node in your cluster. Then you're gonna be planning 128 join reader processors on 128 of the nodes, and that can be very expensive, especially if you're not going to actually need to read all of the data on the right-hand side, which is common. Lookup join, we often plan it when we know that the right-hand side is big, but we're not going to read all of it. If we're going to read all of it, we like to plan hash joins or merge joins because it's sort of more efficient to do those in those cases. So we need to think about heuristics, I think, and it's not really clear what the heuristics should be. And it's not even clear that we should be able to pick a good heuristic that works all the time. Like, we kind of would prefer to use the cost-based optimizer to choose things like this. But the big problem with the CockroachDB architecture as it is right now is that the distribution policies are not taken care of by the cost-based optimizer yet. It's a separate process. There's like the big cost-based optimization phase, like a traditional database where you're picking the plans and the physical plans and doing that by cost. And then that plan gets shipped to a different piece of code that actually distributes the plan. And that second part, the distribution part, doesn't use the costs. So it's quite difficult to have enough information to make the correct choice for some of these things. Like this one is a good example. And another good example of something that we can't really do is broadcast join, which is a kind of join that you can use if you have a small right-hand side table. Instead of doing a hash join or a lookup join or a merge join, what you can do is just send the entirety of that small table to every participating node. And that can be an efficient way of doing a join against a small table. But we can't really do that because the cost-based optimizer doesn't know about the distribution part yet. So we've got a plan for this, but it's kind of a long-term plan. And it kind of makes me feel like this PR that we did last time is a little bit stuck because we just don't have enough information to make the right choice at this point. So I don't know quite what to do with it. That being said, I do want to kind of fix the tests up so we can at least have a chance at merging it at some point. Hail Mary from the same rant as the Martian. I really enjoyed The Martian. I never saw the movie, but I liked the book. That's cool. I'll have to check that out. So we're going to take a look at this. And I guess here, let me edit the project description. So commands, edit, project, fixing up our PR for improved distribution of join readers. The other thing that we might do is enhance this thing to also work with not just index join. So there's a slight distinction in Cockroach between something called an index join and something called a lookup join. Index join is like a special case of lookup join that just joins secondary index rows back with their primary index. And a join reader is the general join processor that can join any two tables. The prototype PR that we have only works in this case for index join, and I'd like to extend it to lookup join as well. And then I feel like we could sort of put it to bed for a bit or something like that. Maybe we could merge it behind a setting. I don't know. So that's the plan. Any questions? What do you guys think? Oh yeah, there was one other idea that we had about this, which I think is kind of neat, which is, so I mentioned that the big downside, right, is that we will statically set up these big, all of these different join readers. So here's the diagram that you can look at to understand this. Like you see these 3 layers down here, the join reader layer. If you had 128 nodes, all of which had data for this line item table, you would have a little box on all 128 nodes here. And that's pretty bad, especially if you're not going to be reading all of that data. So, right, the question is either can we do heuristic to avoid those cases when it's not necessary, or can we make it dynamic? So right now, all this distribution planning, it's completely ahead of time static, meaning after we receive the plan, we create a physical plan that's going to be the only physical plan for the entire query. And conceivably, you could have a system in which you could create like this flow here. This in principle doesn't have to, well, I guess it's just this part. In principle, this thing doesn't have to be set up ahead of time. You could theoretically like notice that you need this by checking the value of the data row that's read from over here. You see how it says by range? This means it's using the data in the row to decide which node to send it to. You could, in principle, like notice when you're seeing a node for the first time in these routers, and then set up the flow on demand. So set this thing up on demand dynamically at runtime. But we don't quite have infrastructure for that, and we think that it's challenging to set that up. So I definitely don't think I'm going to do that right now, but it's something I wanted to mention since it's a possibility. It's kind of interesting. So basically, I want to fix the test for this thing, since I don't actually think that I looked at any of the tests. And in fact, I don't think the tests even compile after last stream. What's an example when this is slow? Hi, Dirter. An example of this is slow is when, so let's say that you have let's say that you're reading only a small subset of this table at the top, just a small subset of the top table, but you don't know that at planning time. Right now, in our heuristic algorithm, it's not really a heuristic, it's just a setting, it's on or off. Right now, when the setting is on, we set up a processor for this query, this second layer down here, the join reader layer. We set up a processor for this on every single possible node in the cluster in which data for the right-hand side table could exist, without regard for whether we're actually going to need to talk to that part of the table. And so if we're just using like a small fraction of the data in the left-hand side table, then it's going to be a lot of upfront setup costs talking to 128 different nodes in a 128 node cluster, for example, when maybe only 10 of the nodes will be actually queried in the end. So there would be a big kind of upfront overhead to certain cases, which could be quite bad. So I think like slow is the wrong word. It's more like high overhead for certain cases. So, does that make sense? What is up, Fly Style? Mystery colleague Fly Style. How's it going? It seems a bit, like an example would be nice. Okay, let me find an example. It's a bit hard to, let's see. So, we're gonna do create table a int primary key b int, and then we're gonna say create table b int primary key, something like this. And let's say we do insert into a select G1 from generate series 1 through 100,000. And then we said insert into B values. Insert into B select star from generate series 1 through 100,000. Okay, so what we have here is you're a SQL engine developer at Hazelcast. Oh, awesome. That's really cool. I remember looking at Hazelcast back in the day at my last job. Hazelcast is the in-memory data network plane thingy, right? I didn't know it had a SQL layer, but that's really nifty. Isn't it so fun to work on SQL? Okay, so here's our example. We've got a table that's full of data. Let's take a look at table A. Select star from A, limit 10. So you can see in the A table that the A column in the A table is always changing, but the B column in the A table is always set to 1. Okay, so this is like the dynamic value of the B column. Whereas in the B table, select star from B, limit 10, the B table just has all of the sequential integers. So let's imagine we're doing a query like this. Select star from A, inner lookup join B on A dot B is equal to B dot B. Or let's just do an explain on this. So the reason I'm putting inner lookup join here is to just force the lookup join operator. The point is that in this particular case, let's also say that this example was much bigger. So we had way more data, and this cluster that I'm looking at, instead of being a fake in-memory data cluster with just one node, would be 100 node cluster or more. In this case, let's also imagine that table B was spread across the cluster evenly, right? So there was a chunk of B on every single node of this 100 node cluster. If I were to run this using this heuristic that we've been working on, it would set up a little join processor on every single one of those 100 nodes. But when we're actually performing this join, since every value of B in this table is 1, it's always going to route to a single one of those 100 nodes, since the one row in this B table is always going to live on the same node in the cluster. So the overhead is very high because we have to set up 100 processors, and 99 of them are going to be useless. They're going to do nothing. They're going to do no work. So that's kind of the reason that it's inefficient. Does that example make sense? We can query our IMAP and other sources. I'm not sure what that is. Calcite? I don't know about any of this stuff. Calcite is an Apache project, right? Is it a contrived case? I don't think that it's a particularly contrived case, no, because the other thing is that it doesn't have to be full table scans only that are going to get run using this setting. It also could be like small scans that only use, I don't know, 100 rows or something like that. We don't have a heuristic setup that says, okay, well, if you're only going to scan 100 rows, then don't bother doing all of this pre-setup because it's too expensive. We need to find what that threshold is. And it's hard to find the threshold. So that's why the cost-based optimizer is something that we'd really like to involve, because trying to do these calculations like on the, based on guesses is not really so good. Yeah, either it needs to be lazy or something else. I think the lazy thing would be ideal, but making the physical planning stuff lazy it's a big lift. It is a big lift. It would be something cool though. It would be very, very cool. And it might actually be worth it. I'm not sure. So Calcite is a dynamic data management framework that has SQL, a query optimizer, and any data anywhere. So it's like a SQL front end, basically, right? It's like a SQL front end that you can plug in backends to or something like that. Do you need the plan to be lazy or just the execution of the plan? Yeah, so the key thing that I'm probably not making it clear, but like to make one of these physical plans in the system today, you actually have to talk. You have to send an RPC to all remote nodes that are going to participate in the query. That's like a requirement based on the way that we've designed the like little distributed query graph system thing, is that you have to pre-RPC all of the participants to tell them to set up infrastructure and begin waiting for network inputs and register themselves with a central registry and stuff like that. So it just happens to be kind of expensive the way that it's implemented. There's no good reason for that. It's just like, that's what happened. So yeah. I think that like those RPCs are expensive. Like doing 128 RPCs and causing those 128 nodes to like do a little bit of work, even if it's just a little bit of work, it's too much work. If they're not going to get used, if it's going to be such a common case like this one, it needs to be a lot more lazy than it is right now if we can to support that idea. It also has an optimizer, and it uses Volcano. That makes sense. I feel like everything... Does anything not use Volcano? I guess like some... Like Postgres is sort of like a heuristic planner, but I feel like everything that isn't a heuristic planner basically uses Volcano or something like it, right? I guess there's also that like graph one, right? Like OGM or something. What is it called? I forget. IMAP Hazelcast. An IMAP. It's a big map. A concurrent distributed map. That's like the big thing that Hazelcast exports, I guess. Hello, Marilia. Yeah, I think that the dynamic idea is good, and we should probably do it. What is this? Okay, let's get rid of this. Oh yeah, I was looking at this Snaplet thing. Do you guys know about Snaplet? It's such a cool idea. Snaplet.dev. So Snaplet is a way that you can get a database copy from any database that is anonymized. And you can use it for your development. It's such a little simple idea, but really such a beautiful website, and also such a good idea. I would really like to get support for Snaplet in CockroachDB or vice versa, because it's just such a useful thing. The idea is like if you have PII in your production data, but you want like a realistic copy of it, so that your development database doesn't have to skew too much from your production database. You can use this thing to redact it. And not just redact it, but also like include realistic sample data based on the contents of the columns. Like first name, last name, it has a generator for that, or like emails or like UUIDs, right? It can kind of infer what fake data should look like. So it's very neat. I was kind of playing with it a little bit. That's why I have this .snaplet. I think I'm going to delete it though. Okay. So that is that. That is that. I think what we should do next is basically go and resolve some of these tests. What is up? Insert many. So how should we do this? Why don't we just run? What should we run? I feel like there should be more tests than this that failed, actually. Like, I kind of thought that things would fail to compile. Maybe I fixed the things. Maybe I fixed the test. I don't think I did, though. Make test, package equals, package SQL call flow. Let's see what that does. Yeah, okay. I thought that this wasn't going to compile. Hello, Dev Deal. How is it going? Welcome into the stream. Hope everybody's doing awesome today. Okay, so let's go ahead and open this up here. Routers test. Okay. So I think what happened here was what? Probably just haven't... looks like this is a test implementation of something, so we'll just add these no-op methods here. Oh, right. Yeah, so we kind of just like refactored some of these methods so that they don't have to take as many arguments anymore. So I guess we can delete this hash calls. I'm going to put this here. So we need an op with meta info, unblocks events, chan, outputs, and then a tuple distributor. Oh yeah, that's right. So I think what we need to do here is give it a hash tuple distributor. Call exec. New tuple hash distributor. And this takes an init hash value, I guess is going to be 0, a num outputs, which is going to be len of outputs, and then this uint32 of 0, which is the hash calls. Okay, so we're going to say distributor is equal to Then we can say distributor down here. All right. And it's going to be the same thing for this. Test hash router cancellation. So let's just kind of copy this this code here. Unless there's something that I'm missing. Is there like a shortcut for making one of these things? It's going to be easier. It doesn't really look like it. I guess I could make one. New hash distributor. Or new hash router? No. Yeah, I don't think I'm going to bother. I think I'll just... It's just a tiny little bit of boilerplate, so no big deal.
Databases don't scale because they use joins, and write to disk.
Flystyle, thank you so much for the fresh tier 1 sub. I really appreciate it. Welcome to the stream. Hope you stick around and enjoy those emotes. Okay, so we're gonna pass in our distributor over here. Distributor. Do I need to seed it with something or something like that? What did I do? I think I got rid of it from before. But maybe it's...
Computers hooked into over 1,000 data banks throughout the world.
Yeah, where must have changed new tuple hash distributor, right? So it's actually something different. It's call exec hash dot default init hash value +1 for some reason. Oh wait, no, that can't be right. It's just default init hash value. You didn't imagine that you'd meet a database developer on Twitch? Well, today's your lucky day, my friend, Flystyle. Today is your lucky day. No, I'm just joking. Yeah, it's fun, you know. What can I say? What can I say? Default init hash value. So what kind of stuff do you work on in Hazelcast? You started a half a year ago?
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
Migration tolerant index scan of IMAP. That sounds interesting. What is up, Bro Hunter? So the project is about teaching join readers to get planned on the right-hand side data locations. That's the idea. So pushing them to where the data that they are going to be reading should live, instead of planning them where the left-hand side of the join is going to live and forcing them to do RPCs to get the data that they need. What is a distributed database? That is a great question. A distributed database is a database that runs on multiple nodes at the same time. So a non-distributed database would be a database that runs on just one computer, and a distributed database is a database that has multiple computers talking to each other over networks and replicating the data between them. It means that the left-hand side, it doesn't have to do RPCs in the same sense. It can push. So just like a one-way RPC kind of thing. You know what I mean? It's kind of sending the data that it wants away to somebody else, and somebody else does work and then continues pushing the data that they get down the graph that they need to. Like the key is kind of looking at this picture over here. So the left-hand side is the table reader. The left-hand side pushes rows to the join readers that live on other nodes. The join readers do work, and then they continue processing just on their same local node, rather than having to send back to the original node that that requested the data in the first place. Yeah, Postgres is not a distributed database, but there's pieces and things that kind of build in different kinds of distribution on top of it, sort of. Okay, so num outputs in this case is what? I have no idea. I guess it's len of output dot streams. How can I know the right number of outputs to do here? So not all the machines share the same data, but subsets of them share chunks of the same data. So in CockroachDB, the way it works is that all of the data in the database is divided up into ranges. And a range is kind of an arbitrary chunk of up to a certain size of data. I think by default now it's 512 megabytes. And those 512 megabytes are replicated to 3 by default of the nodes in the cluster. So you could have 100 nodes in the cluster, and each chunk is replicated to only 3 nodes in that 100 node cluster. You can change the replication factor, so the number of nodes that the data is replicated to, but that's kind of the idea. But helping solve having higher traffic is one reason to have a distributed database. Another one is fault tolerance, availability, durability, and things like that. So making sure that if that one computer crashes, right, you can still get at the data, kind of thing. The name of the theme, if you press !theme in the chat, you can find out for yourself. Okay, so how do I know the number of outputs in this thing? I'm like really not sure. I'm really not sure. Is it just... I guess it's just one, right? Okay. Just one more of these to do. Yes, so that is one of the big problems with it, is that it makes the number of join readers is equal to the number of nodes that contain leaseholders of ranges on the right hand side, which could be up to the number of nodes in the cluster. So that's probably the biggest problem with this. We would need to come up with a better heuristic for when to use it to actually turn it on. So, but it is fast. Like if you were to test it on a query that needs it, it is quite fast. You introduced useful SQL operators. Nice. Never dealt with more than one database for a project since you work on low traffic and non-data heavy applications. What are common use cases for something like Cockroach? So Cockroach we think of it as a good OLTP database. So OLTP stands for online transaction processing. And you can think of an OLTP database as something that you'd want to use for a shopping cart application or a distributed ledger or a game or something that needs a lot of small queries that might contend with each other. So, people all checking out from a shopping cart at the same time, you want to make sure that people don't re-buy something that's sold out or something like that. Or maybe something like a Twitter or a chat application, anything where you're doing a lot of rapid queries, you have a high throughput and it's sort of your system of record. That's another thing that people like to talk about when looking at databases like Cockroach. It's not an analytics processing database where you have a lot of data that you need to sort of sort through. It's sort of your system of record, the thing that you put the data from your application into and use that as the source of truth, so to speak. HTAP, yeah, HTAP is a pretty good buzzword. I think that Cockroach is close-ish to an HTAP database because of some of this stuff that we've been talking about, like the fact that it has the vectorized execution stuff and the distributed query framework on top of it. I think you could argue that it's sort of HTAP, but we usually stay away from calling it HTAP because it doesn't really find the right business that we do best with right now anyway. Yes, it does mean that distributed databases are safe in the sense that it's harder to lose data when you have a higher replication factor. It's very easy to lose your data permanently if you just store your database on a single node. You know, even if you don't lose the entire node catastrophically in a fire, you could have, you know, silent data corruption, and it would be hard to notice that since you only have one copy. Do people also expect in-memory storage for an HTAP database? Do they? I don't know. I actually don't know. I don't think so, but I'm not positive. I think they would probably expect at least semi-columnar storage. Yeah, definitely. Postgres MySQL failover strategies are a headache. I've never tried to use them, but I hear that. Or rather, I've heard of that before. Yeah, isn't Hazelcast like only in memory? Or did I make that up? I thought it's kind of mainly an in-memory system. Okay, so here's our tuple distributor. See if we can run our tests now.
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
How does performance compare? So I think the old school single node databases like MySQL or Postgres are very fast at a lot of different things because there's less overhead to just working on a single node, but they don't scale as well. So you kind of hit scaling limits with single node databases. They're very efficient and very fast due to the way that they're programmed, but once you hit a certain amount of throughput, it is hard to scale them at all. So kind of in the end, if you want to go past a certain scale and you want to build a internet scale website, it would be very, very hard to build one of those on a single node database. But then again, like some companies do find ways to do it. Like Stack Overflow, I think, is very famous for running their entire website off of some like giant machine that runs MySQL or something. I forget exactly what it is, but there's definitely ways to do things like that. But most of the other kind of internet giant companies, they all run distributed databases. Is that GitHub too? I don't know. I would be surprised. Oh, well, so Facebook is famous for running their whole graph database on top of MySQL, but it's some kind of like insane distributed sharded MySQL thing, I think. It's definitely not just a single instance. That would be pretty insane. GitHub uses Vitess. Cockroach being slower with complicated queries would be a nice way to find performance bottlenecks early and squash bad queries. Right, yes. The old school databases, they're too fast at running bad queries, so you never notice until it's too late. Is that what you're saying? It's kind of a funny way to put it. Not sure how I feel about that. Hasura seems really, really cool. So Hasura is like this thing that translates GraphQL into SQL or something, right? Or it's some kind of GraphQL server. I hear that it's awesome. I've never used it myself, but I hear that it's very neat. We really would like to get better support for CockroachDB in Hasura. Blockchain thinks serverless is overrated. Say more. I think people have a lot of different definitions of serverless. I think that some things about it might be overrated, but some other concepts about it I think are very, very good. I think that the best concepts about serverless are things like metered billing and transparent scaling. I think that those things are extremely good, and other things about it might not be so good, like the way that things like building an app using only cloud functions is quite difficult. I think that might be overrated, but I think that metered billing is the future, and it can be good. Had to fix dumb queries that the ORM was generating. That's life. That is absolutely life. The internet is just entirely overrated. Okay, so we're gonna make a new hash distributor here. Let's see. Create an allocator for each output. There's got to be a num hashwriter output. So we'll set this to num hashwriter outputs distributor. All right. How about now? Serverless is good, but not for every use case. Everyone wants to get on the hype train. Yeah, I think that's a pretty accurate way of putting it, Pratik. I think people love hype trains, and it's always important to examine your use case before jumping on a hype train. Serious question, does it make sense to get a PhD about databases nowadays? I have no idea. I never really did. I never did anything past undergraduate, so I don't know. I think I work with several people who do have database PhDs, and they're amazing. So I don't quite know what to say. I think it's a difficult question that definitely does depend on your goals, just like Brohanster is saying. I don't know. I don't have a personal opinion on it. I really do think it's very situation specific, right? About cloud architecture, should I deploy all the nodes of the distributed database in the same region, or can I achieve high availability in different ones? That is a great question. So that's one thing that CockroachDB does better than most other databases, which is that you can actually deploy it, the same distributed database instance, in multiple regions all at the same time by adding nodes to all of the regions. A lot of the distributed databases out there really want you to put a cluster in each region and asynchronously replicate between each other or shard in some other way. But one thing that's really strong about Cockroach is that you can actually make a single unified multi-region cluster. Cockroach also has multi-region primitives that you can use. So commands like add region, or you can make tables that are sort of region specific or sharded by region, etc. We have some pretty good documentation about it, but that's one thing that's pretty unique about CockroachDB, that it is multi-region. Yeah, Safe, I saw that tweet. What do you think about that? I had to laugh about that tweet a little bit, to be perfectly honest. The problem with pay-as-you-go serverless databases is that the cost of non-cached and cached data or queries are the same, and you end up paying a lot more. That's a good point. Interesting. First race condition with multiple API calls, sometimes triggering a database constraint error on insert. Let me send you guys CockroachDB multi-region docs. Take a look at this page, and this page maybe. If the database is slow, it will make the experience less desirable. Yeah, I think so. I think that's true. I think that the tweet probably should have said that at a certain point, the quality of the database itself has to be table stakes, right? I think that would be the charitable way to interpret it. But as written, it kind of said, it doesn't matter. The internals of the database don't actually matter at all. And the only thing that matters is developer experience, which I thought was quite funny. Safe, maybe you could link the tweet for Bro Monster. Yeah. Okay, so anyway, it looks like we got these tests to pass, which is pretty awesome. Performance matters, right? Okay, so we're gonna... guess we want to commit amend here. Yes, exactly. Roach Rail has got it. Roach Rail knows. What other tests are failing here that we can take a look at? So we need to look at these logic tests. Let's do that one first, actually. So dist vectorized. Dist vectorized. Okay, so we're gonna say make test base logic files equals dist vectorized. Huh, I'm actually not quite sure why this one would have failed. We'll just run it like this and see what happens. Cool. Flystyle, thank you so much for stopping by, and thanks again for the sub. I stream every Friday, so I hope to see you next time. So, wow, this is a big... Oh, I see. This would have changed because we renamed it from callflow.hashrouter to callflow.router, which is totally fine. So we're just going to go ahead and rewrite these. So we're going to say test flags equals rewrite. Oh, man. It's a funny tweet, right? Pretty funny stuff. I think, okay, here's my take. Here's my take on this. Real talk. I think that you have to have both. I think that the core of what they're saying is absolutely true. The core of what they're saying is that developer experience is important, and databases should be concentrating more on developer experience than they have concentrated on it before. I think that's absolutely accurate. Databases they're too hard to work with, and for new developers, it can be intimidating. And we should be getting rid of that as the database industry. I think 100%. Because, there's more and more developers. Everybody should be able to use the database. It shouldn't be left to the experts only or something like that. So I really do agree with the core of what that tweet was about, that developer experience is central. I just think that you need both. You need a solid database with solid infrastructure and a solid developer experience to have a successful database. Yeah, Amit, you can go ahead. No guarantees that I can answer it, but go ahead and ask. Maybe someone from the chat can help too. All right, so next up we have some other stuff. Exported should be commented. Okay, so we just need to add some comments here. So range distributor. Yeah, agreed. No one will buy a database just for the developer experience, but having a great developer experience can seal the deal. Agreed. I don't think I agree with that opinion, Denny. That's pretty dismissive towards people who use JavaScript, and also the entire modern web is built on JavaScript. So, I would definitely reconsider before you say something like that. Modern web developments, it's pretty complex, difficult, deep, interesting, and you have to respect it. That's what I would say about that. Also, the concept of thinking that a certain programming language makes you a man or not is ridiculous, and you should lose that attitude. Sorry for the tough love, but you shouldn't say stuff like that. Web is the answer to JavaScript. I'm not sure what web is. Okay, so our exported function new tuple range distributor should have comment. Okay, so new tuple, right. New tuple range distributor constructs a new tuple range distributor that I mean, what can you even say about a function like this, right? That routes tuples based on the given mapping of data to spans. Given mapping inside of the spans parameter using the given set of encodings, one per input type, and sends them to the given number of outputs. If a particular tuple doesn't have an associated output, judging by the mapping in spans, it will be sent to the stream, to the default dest output. Okay, so next up we have init. So we'll say, what is, I mean, see here. Init initializes the tuple range distributor, gets it ready for use. It must be called before use. And then the last one is distribute. I'll just say distribute implements the range distributor dot distribute. I'll just say range distributor interface. What's the adoption percentage of Pebble compared to RocksDB? Well, RocksDB is no longer supported in the database, so anybody who's upgraded past whatever version that was uses Pebble. And I don't exactly know what the percentage is there, but we don't really have lagging what's the word? Clusters. we don't really have customers that have lagged past that. Yeah, haven't upgraded to the Pebble version. So I don't know the percentage, but it's high, and it'll continue rising. Yeah, we don't have a problem. I mean, the Pebble adoption went really well, and yeah, it's good stuff. Yeah, RocksDB is completely deprecated. It's not just deprecated, it's removed. So it was deprecated and then it was removed altogether. Danny, I'll accept your apology, but it's just, you know, it's for you, right? You shouldn't say stuff like that for your own sake, more than for my sake. Amit, I need to store metadata of folders and its content, like parent folder ID, file name, and not the actual content. Only need to store directory tree structure. Should I use SQL or NoSQL database, considering which database will result in less complex CRUD operations? That's a great question. I actually was working with somebody on implementing something just like this with CockroachDB somewhat recently. And it actually really depends on whether you want range scans. I think a lot of the time, what people really want to do is list the files in a directory. And you need to think about the way that you want to represent that. I would say that implementing it in SQL is a good idea because the richer SQL data model will allow you to do more things with your data. It'll be less painful to program against. I don't see a strong reason why you would want to use a NoSQL database for something like that. So I'm a SQL fan, but I don't think there's any strong reason to use NoSQL for something like that. It also depends on the access patterns, which you haven't really shared. But I think that it can work just fine with SQL. Okay, so let's go ahead and move to the next broken test. Test GC assert failed. That's interesting. So test GC assert, right, is that this is this little program that we wrote, a little linter that makes sure that we don't have any bounds checks for certain lookups, and it looks like we haven't successfully satisfied the linter here. So let's try to figure out why. It looks like what we need to do to satisfy the linter here would be to force. I mean, I don't know how important. Well, no, I think it's pretty important. I think what we'll do is we'll slice into output IDXs up to n as the way to avoid having to do a bounds check here. So this is kind of a neat trick. What if I say nothing is equal to output IDXs of n? Or is it n minus 1? I think it's going to be n minus 1. If I say this, then the compiler will be able to infer, I think it should be able to anyway, that it doesn't need to do a bounds check when looking at I here, since it can prove that I is always going to be less than n. Since we're doing a range loop over n things, it kind of, there's a little algorithm inside the compiler that says, okay, well, since I've already checked up to n minus 1 and this thing didn't blow up and have a panic, I can avoid having to check that down here. And I think I can do that twice. And this should prevent the bounds checks, hopefully. Hopefully. So we'll try that out. So the next one, also in this file, looks like I just didn't really run any of the tests on this file before pushing last time, which is definitely true. Okay, so in this case, we need to say call exec error internal error. Oh, I see. So call exec error dot internal error. So we're not allowed to use panics in the call exec packages. Instead, we use these special wrapper methods that panic, but don't actually crash the entire program, which is a better thing. User can navigate between folders, move files between folders, rename files or folders, change order of files, delete folders and files, nothing else. I mean, I think inevitably what always happens is that if you use a NoSQL database, you're eventually going to want some kind of relational quantity or relational quality of your data. And I don't know exactly like what that might be. Maybe it's like the file order. Maybe you would have a separate store of that, or then you would need to reference it somewhere else. And then you'll end up having to do relational data inside of a NoSQL database, which always, every single time ends in pain. So that's my caution for you. If you ever have relational data, or you expect to have relational data, make sure that you're not using a NoSQL database to store that data, because you will mess it up. And it's not going to be your fault either. It's because the transaction model in NoSQL databases makes it extremely easy to make mistakes and let your data become inconsistent. So if you need consistency, if you need relational data, you should be using a SQL database. Hi, Sora. Nice to see you. Thanks for stopping in. Okay, so what's next? I think this one I fixed, maybe. This one I did not fix. And for massive performance, disable the write-ahead log. For massive performance, just route all of your writes to dev null. Turn off fsync. Just YOLO it, you know. So what's happening? Span shadows declaration at line somewhere else. Okay. And there's a print line in here, which needs to be deleted. Wait, what is this? Oh, this can just be deleted altogether. And what is this? This seems to be a non-thing. So I think we should just delete it. And we can get rid of this to-do. Okay. So this is just saying that we didn't, our test didn't compile before, but I think it does now. Reset for tests is unused. Reset for tests. Is it really? No, I think it's just, it wasn't compiling before. And this thing also wasn't compiling before. Okay, I think basically we're probably good to go at this point. So let's see. I think this one needs to be amended to the first commit. Oh my God, what the heck? Did this break because I installed this GH thing? I think I need to delete this. I'm just gonna... how do you dpackage-l grep gh sudo apt-get remove gh? Okay, let's try not to leak my password here. Okay, try again. What the heck? No, everything is ruined. I broke my little... Man, I'm gonna have to fix this later because I have no idea what this is and why it's not found. This is the thing that's supposed to, you know, pop up the list of all of the Git commits in my history and stuff like... Did I just, like, break my entire environment? No, we're good. I think we're fine. Okay, we're just gonna deal without that special little thing. Even I'm so used to it though. Oh my gosh, this is crazy. Git commit fix up. So if you guys haven't used FZF, FZF is like this amazing thing that allows you to write these little mini programs that basically do fuzzy completion for you for all sorts of things. So I have a little fuzzy completion thing for all of the commits in recent Git history that I'm using constantly to do git commit fix up. And without that, I feel crippled. It's not good. So we're going to add this one. And I want to do it again right now. I want to do git commit fix up and then control GH, and then that doesn't work. So instead I have to get this, copy paste it. Terrible. Truly terrible. I don't know what I did to my... Like, I don't even know how to use my computer without this, apparently. Does it ever happen to you? How does one... Like, don't even remember how to... There we go. Okay, so git rebase I origin master. Okay, so we're going to go ahead and push this. And now what? I think now what we could do is probably extend this work to work with lookup join as well and not just index join while these tests run. And we can see how that goes, basically. Mateus, nice to see you. Okay, so the next thing, right, we need to figure out how to distribute the join reader general case as well. So let's take a look, get show like this, take a look, and yeah, so go ahead over to our dist-SQL physical planner. So this file is basically the subsystem that I was talking about earlier that is the thing that happens after the optimizer. The optimizer runs, it gives us a plan, and then we convert it into a physical plan using this big heuristic file. This is the thing that we'd really like to live inside of the optimizer, but we haven't gotten around to doing it just yet. So, create plan for lookup join. There should be such a thing, right? So I actually don't even think this is going to be this hard. So basically, create plan for index join. This is what we did last time. We had this cluster setting. Let's actually rename this to match its name in SQL. So in SQL we called it dist-SQL.distributedJoinReader.enabled. So, but it's actually called enable distributed index joins as a variable. So let's call it enable distributed join reader. And then that way we can use it for both index join and lookup join without it feeling weird. And the main thing that we do is we have this big if. We run this giant thing if the setting's on. I wonder if I can actually pull this out into a function, because I bet it's going to be like nearly identical. But we're going to grab it and copy paste it for now to see what needs to change, just so I can even remember what is even going on in this code. So let's go to where it says plan lookup join. Where is that? Create plan for lookup join. So I think basically it's here where we will want to, instead of doing this no grouping stage, so a no grouping stage is, if we go back to this sample diagram, a no grouping stage is a kind like the aggregator, where for every stage, or rather for every processor in the previous stage, so this, like basically a horizontal group of these yellow boxes is a stage. A no grouping stage is where we add a copy of a given processor for each of the processors in the current stage. So this aggregator is a no grouping stage. We add one of them per previous stage. And what we're going to want to do is replace, in the case of lookup join, it's a little confusing because lookup join and index join are both planned with join reader. So basically we want this diagram to also come out when we use an ordinary lookup join and not just an index join, which is what it's doing right now. So I think we just want a big if here. And the trick that we need to do is, I think the main difference between this code and the other code is really just going to be this one line, honestly. Maybe. Now we also need to figure out the key columns. So there's like a few differences. Let's just try to figure it out. So the first thing that we need to do is figure out that what index the right-hand side of this join is going to be. In the first example, what we did is we just looked at the entire primary index of the table, because index joins are hard-coded to look at the primary index of a table. But in this case, since we're doing an arbitrary join reader, we need to figure out what that index actually is. Or wait a minute, we're not even using... Oh, no, we are. So there's an n.table.index and an n.table.desk. And I guess this n is what? This is the lookup join node. And the lookup join node contains a table, which is a scan node. Okay, so I see. We basically just want to say... I actually think that this code is already correct because we're making an index span based on the table in the lookup join node and based on the index in the lookup join node. And this is already what it's doing. So far, this code is the same as the index join case. Then we partition our span. So what this is doing is saying, get all partitions. I guess it's sort of not really all partitions, but partition the span into a mapping of nodes to subspans. I guess mapping of nodes to the list of spans that have leaseholders on that particular node. So probably this is going to be a more clear way of saying it. Finds out which nodes are owners for ranges touching the given spans and splits the spans according to owning nodes. The result is a set of span partitions, one for every relevant node, which form a partitioning of the spans. So that's what that does. And then what we do is we create, we sort of munge this data into the form that we need to send to this range router guy, which is what this orange box is, the range router. And the range router is a piece of code that dynamically chooses which node to send a particular piece of data to based on what's inside of that data row and based on that mapping from span to node that we just created. What's up, Spartan? Arcane magic. Databases and networking both contain some tricky code, but certainly this is not something that you cannot understand if you stare at it for long enough. Probably true for a lot of different things. So the key columns, I guess we don't have that in this particular thing. And I guess instead of key columns, I think we want to look at these eq calls here. So n.eq calls, right? Eq calls represent the part of the join condition used to perform the lookup into the index. It should only be set when lookup expr is empty. So what is lookup expr? When the lookup condition is more complicated than a simple equality between input columns and index columns. I think what we want to do is not run this code if lookup expr is set. So we're going to actually add a condition for that, because the lookup expr stuff is fairly complicated and I don't really understand it. So we're just going to ignore that case. We're going to say if n dot lookup expr is equal to nil. So I guess we'll invert the condition here, and n dot lookup expr is equal to nil.
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
So we can't use a distributed join reader. Let's say we can't distribute our join readers to remote nodes if we don't have a static set of equality columns, since the range router is not configurable to do its work with a dynamic expression. I guess this is an enhancement. We could conceivably enhance the range router to handle this case if we wanted to. Can you stay? You're not a database programmer? Yes, absolutely. Or MSAL, everyone is welcome. I think one thing I like about doing this stream is that it hopefully gets people interested in databases and database programming, or using databases, or messing with them, or just interested in databases in general. So certainly it's a every person is welcome kind of environment, and feel free to ask questions. I love talking about any kind of database questions that you might have. So we're working on CockroachDB, which is a distributed SQL database that exists already. So in a sense, we're creating it from scratch, but we're definitely, we haven't, a lot of people work on CockroachDB besides just me. It's a big project with a lot of contributors. So we're not starting from square one.
They
You try to learn SQL, but you always forget all of it. You'll if you need to use it for work or for a project, you'll get the hang of it pretty quickly. SQL is not. I think SQL is very learnable. It's definitely, it's got its ins and outs and tricks, but it's definitely not something that you cannot learn. But hello, MSAL, Addo, and Spizer. Welcome in, you guys. Thanks for joining. Definitely ask questions if you've got them. Okay, so we do this partitioning, blah, blah, blah. And then instead of iterating over the key calls, we're going to iterate over the eq calls. And then I think that's really all there is to it. So honestly, I think that we can pull this thing out into a function. And let's go ahead and do that. So we're going to make this whole thing into a function that can be shared by both the index join planning code and the lookup join planning code. So we're going to say extract method. It's easy to pick up basics, and then it's easy to forget if you don't use it much. I think that's definitely true. I don't think that all of SQL is necessarily easy. Like, there's definitely some tricky bits to SQL. I think the basics of SQL are definitely pretty learnable. But yeah, I could see forgetting it quickly if you're not using it. It's only available in 1080p because I'm not a partnered streamer is the main thing. But I think sometimes affiliate streamers like myself get quality options, but only if Twitch is not, like, if it has spare capacity or something. So I think sometimes the stream gets quality options, but not all the time. So yeah, if you want to have quality options, you better tell all your friends to come watch the stream so I can get that 75 person average that you need to get partner. I don't think, yeah, not quite sure we'll ever get there, to be honest, but that's okay. Only the highest of quality in this stream. Exactly. Yeah, you're in a queue if affiliate. That makes sense. Okay, so this function is going to be called, we'll call it distribute plan distributed join reader, I guess. Okay, so we're going to say, ooh, but it takes a lookup join node. That's actually kind of annoying. So I think we need to refactor this a little bit. Instead of taking the lookup join node, I think we're going to have it take this scan node. Hey, thanks for the follows, you guys, by the way. All right, so that's that. And then I guess we should really also probably pass in these equality columns as a variable. So we're going to pass in, I guess we'll call it, it's sort of the lookup columns, right? Lookup calls int, something like this. And then this can be for range lookup calls. Lookup calls. Okay. Ooh, and then we also need a required ordering, huh? That's awkward. What is this required ordering about? What is this rec ordering about exactly? Looks like in this case it's set to just the rec ordering. Okay, whatever. We'll just pass it in as is. So we'll say the scan node, the lookup calls, and then the rec ordering. All right, and then we basically get to say, We'll need to pass in our n.table. We need to pass in our n.ec calls, and then we'll need to pass in our n.required ordering. And then the magic is that in the other case, we can use this very same function rather than have to repeat it. This is the magic of DRY, baby. What's up, Kosakui? Welcome back to the stream. How's it going? So we're going to say dsp dot plan distributed join reader, plan context, and we have to pass a bunch of crap in here. Plan context, n dot table, n dot lookup, n dot key calls, n dot rec ordering. So do we actually need to pass this plan thing in though, or can we just get this from? No, I guess we do. Plan. The join reader spec. Join reader spec. I guess we do need to pass that in, huh? I don't really get that. Why do we need to pass that in? Because we need to plan it, obviously. Okay, that makes sense. Join reader spec. Post. Types. Return this, and then we're done. Okay, so then we can delete all this stuff, which is kind of cool. I thought you couldn't do I is equal to range something since range has both index and value. Yeah, so in Go, if you just use a single left-hand side variable like that, it gives you just the key, just the index in the case of a slice or array, and just the key in the case of a map. So it's kind of neat. You can do either. No, that's not new. I think that's been around forever, but I'm actually not positive. Okay, so I guess we'll call this create distributed join, create plan for distributed, no, distributed join reader. Okay, we'll say create plan for distributed join reader. Plans a join reader processor by placing it on all possible nodes that contain ranges, that own ranges, we can say own ranges of the right hand side of the join. Yeah? It's basically all there is to it. Is using the index to pull items of a collection faster than just using the item range gives you? No, they should be basically the same. The one thing to think about there, Evil Jaws, is whether the value in the collection, let's say you're looking at a slice, let's say the value in that collection is a non-pointer type, so a struct that contains a lot of data. If you do the form, for I comma v in range that slice, then at every element, it has to copy the whole struct into that v variable. And if the struct is big, that could be expensive. And sometimes what you want to do is actually just look at one of the values in that struct. If that's the case, then you shouldn't use that form because it'll be just pointlessly expensive to do the copy. And what you can do instead is get the pointer to that struct by saying, address of collection of I. And then you can say, yeah, you can get just a member of that thing without having to copy the whole thing onto the stack for no reason. So that's a little trick. It usually doesn't matter much, but it's something to think about. If you're doing range loops over slices that have values and not pointers in them. I think I need to add and distributing data from the stage before to the join reader stage by using a range router, using a by range routing policy that picks the node based on the value of the routing columns of the lookup calls in the data rows, input data rows. Okay, so something like that. So we now use this twice. And that's about that. So I really think that that might be it, actually. Well, we should make a little test case. So we're going to go to dist join reader. And let's see how we can let's see if we can create a, so here's my test case for the index join case. I want to see if I can create a test case that uses join reader that's like basically the same as this, but it uses a lookup join instead of an index join. I think it should be possible. This is kind of an intense song. I'm going to skip it. Okay, so basically what this test does, let's take a look at it. I feel like all these songs are too intense. Like I want synthwave that's not intense. Does that exist? Like they're all so intense. Maybe that's kind of the point of synthwave then. I like this. Okay, so the point of this test, right, is that we've set up a single table and we're doing an index join from one of the secondary indexes to the primary index. So I'm wondering whether what we can just do is a self join and force it to be a lookup join or something like that. Kadobes, what's up? Hope you're doing good. I think that we should be able to make this a self join somewhat easily. So we can say query t explain this SQL, select some int of b, some int of, I guess we could say t1.b, some int of t2.b. How's this gonna work? .b from t1 inner lookup join. I guess we have to do a because it's got to use an index that exists. So t1.a, t2.a from t1. So this is an alias. Inner lookup join t2 on t1.a is equal to t2.a. Does this work? We'll soon find out. Okay, so we're going to say make test base logic files equals dist join reader. And we have to recompile the entire world for some reason. I guess we rebased. We haven't done that in a while. Oh, Lord. This might take a bit. So, should do a dance break. What would you guys think if I had like a dance break segment? That'd be pretty embarrassing for me, since I feel like my dancing skills are not really up to par. It's not really what I advertise here on the stream. The dancing skills, right? Imagine if I just became like a TikToker, you know? Learn to dance. Kung Fury? What is Kung Fury? This is like our compiling dance, you know? Our compiling music. Do you guys remember the Numa Numa Ye guy? Okay, wait. We have a problem. We have a little bit of a problem. We have a little bit of a problem. You had no idea until I started working more on data engineering stuff how much waiting is involved in coding. Oh yeah. You gotta wait all the time. Okay, so there's a SQL panic has occurred. Index out of range 1 with length 1. Add aggregators. Okay, so I've screwed the pooch. It does not work. It does not work, but why? Create physical plan for plan node. Add aggregators. Okay, so this is a little bit scary because this is saying that our join reader planning code created an invalid plan that then the aggregators code is like not, it's like choking on or something. So let's take a look at line 1649 of this file here. 1649. So have you done a lot of coding learning, Kadobes, for this more data engineering stuff that you're doing now? Or is that something that you had done in your past life? Kind of curious. DB Life, that is right, Parry. So it looks like maybe we've misset our plan to stream call map, possibly. Let's pull this out into another variable so we can see if it's the one that's causing the problem. So much learning. Oh, that's so cool. Did you take courses to do it, or did you just kind of do it as on demand, as needed? How did you do all the learning? Okay, so it's dying on line 1649. Plan to stream call map. So we're missetting our plan to stream call map, which is not great. Oh, you know what? I think I know what it is. Maybe. Do I? Don't I? One certification, halfway studying for another one. They have study guides. That's interesting. Take me with you. Learn from the study guides. Yeah, I guess that makes sense, huh? That's actually kind of genius. Those certification people, they also function as teaching authorities if you're willing to spend time learning the study guides, I guess is what that's saying, right? Seems good, honestly. It seems like a good way to increase the talent pool rather than forcing people to take expensive courses or something like that. Although maybe the certifications are paid, I don't know. They probably are, right? Obviously the certifications are paid. I'm so naive. Of course you have to pay for stuff like that. So why? Plan.plan to stream call map is equal to plan to stream call map. I feel like this is the issue, is that we do not update our plan to stream call map, but we did it in the index join case is my guess for index join. Procrastinator mastermind. I have a blog post about my setup that you can read, although it's a bit out of date at this point. But if you look in my bio on Twitch, you can see my blog post about my setup. So where are we updating our plan to stream call map? It's over here. So I think what we need to do is just pull this setting, setting the plan to stream call map for lookup join up by a little bit. You can in fact learn about that with a special command in the stream. I guess I do need an exclamation point gear one if people are saying that. Do I have a setup or something? No, I don't. I should make a command for that, huh? I should. Okay, so we just need to grab this thing, right? I think we just need to put this up here. Let's try that. Is that going to fix our problem? Let's see if that fixes our problem. Okay, here's what I'm going to do to get my setup link real quick. jordanlewis.org. So here's my blog post. Here's my blog post. This thing, right? So I'm going to say commands add gear. I wrote a blog post about my desk setup, although it's a bit out of date. Is there a commands alias? No, I guess not. Well, whatever. Whatever. Well, whatever. Okay, so what is the difference now? So this looks like it succeeded. That's very exciting. And why don't we take a look at the diagram? The diagram looks like this. Moving things around to fix an issue, best engineering pattern. I know, right? Isn't that epic? Okay, so check this crazy plan out. This is exactly what we're expecting, which is that we see a table reader for one of these indexes getting planned on 3 of the nodes, since that index only lives on 3 of the nodes. And then we plan the join reader. So this is joining against the table, the right-hand side table. In this case, we've just chosen itself to join against, but this could in principle be any other table. And we're distributing the join readers to all of the nodes that could possibly contain data for the right-hand side table. So in this case, since there's data for the T at primary index on nodes 1, 2, 3, 4, and 5, we place a processor, a join reader processor on each of those nodes, and we route each data row from the input by range to the proper node. And by range means we're expanding the lookup columns for the join, the equality columns. And we're comparing them with this static set of spans that we set up that say, okay, if you see a row that has a particular value and we know that that particular value lives on this node, send the row to this node. So that's what this means. And it looks like it's basically working well. We should probably add some tests that use more than one equality column just to make sure that things aren't broken. So why don't we actually go ahead and do that as well. So let's go ahead and edit our test case here.
I have to narrow down the search.
Yeah, exactly. So the secondary index is only distributed to nodes 1, 2, and 3. I just sort of manually set up the data distribution for this case so it would be easy to test. But so I sort of forced the secondary index to just live on these 3 nodes, and I forced the primary index to live on all 5 of the nodes. Okay, so, yeah, right? That's absolute cat jam. I love that little cat jam. So cute. If you guys don't see a little animated emote where it says cat jam, it means that you don't have Better Twitch TV installed. So you can get that extension. That's important for watching Twitch. People love their BTTV emotes. Okay, so to make this good, I guess what we'll have to do is make another... it's a little annoying. It's a little bit annoying, to be honest. But we should probably do it, right? I think what we basically need to do is make either this second... Well, we'll make the primary index contain more than one key. It's just kind of a pain is all. I'll have to change all of the tests. And I'll have to change all of these things as well. I'm so lazy. Maybe I should do this in a unit test rather than this big integration test thing. Rat jam. I'll do this in a unit test. Okay, so here's what we're gonna do. We're going to run this again with rewrite, test flags equals rewrite. So that is going to actually add the new output to the test. And yeah, so if you guys don't have better Twitch TV, this is what you're missing. Check, do you guys see it? You see the little cat? Isn't this worth it? Totally worth it. It's just so cute. All right, so then we're gonna add this. We can add this to a new commit, honestly. 1, 2, git commit. We're gonna say this we'll call SQL. Add plan lookup joiners. Well, maybe we should just amend it to the first commit, honestly, because it's so similar. Let's see what we wrote in the commit message to the first commit. Add distribution policy for index joiners. I think I'm just going to amend it to the first one and then change it to say joiners instead of index joiners. So we're going to git commit, fix up. All right, we can't do this because for whatever reason this is broken. We'll just copy this SHA. Git commit, fix up, and then paste this thing in. Git rebase I already did master. And then I think what we can actually do, let's make this a squash instead of a fix up. So that way we get a chance to edit the commit message. So we're going to say SQL add distribution policy for join readers. Distribution policy that plans a join reader stage by putting a join reader processor on each node that contains a leaseholder for range. It comprises the index, the right-hand side index being joined against. This policy then causes the inputs to the join reader to be routed by the range, so the inputs produce batches of data for the join readers to join against. Release SQL change to add the join reader enables cluster setting, which controls a new join reader distribution policy. Stream cutting out. I think it's just you. I'm at 0 dropped frames, so I'm hopeful that means that that the stream is not getting cut up, at least at the source side. I'm guessing that that's a you problem, Stu, but I'm sorry. Okay, so let's go ahead and git push fmine. You get that sometimes when you have low latency enabled. Okay, so we've pushed this. I guess we should probably change this as well. What's up, Leet Rose? How's it going? I think what we'll do here is we'll copy the, well, we can do it from the GitHub website. We're going to copy the commit message that we changed from that first commit and then edit the pull request contents as well to reflect, so we're not having mismatches. All right. Man, wouldn't it be cool if this could be dynamically planned, though? Wouldn't that be so cool? Should I try to work on that, or is that completely nuts? I feel like it might be a little bit nuts. The idea of the dynamic planning would be that we wouldn't call up these nodes 4 and 5 until we saw a row that needed to talk to nodes 4 and 5. And then at that point, we would call it up and do stuff. I feel like, I guess I'm a little curious to see what that would look like. So basically the way that this works today is that there's this RPC called setup flow. And the setup flow RPC is supposed to get run ahead of time before a query runs. It runs schedule flow, and that starts some Go routines and does a bunch of stuff. Basically sets it up to listen to incoming data. And it additionally one thing that's very annoying, you guys, about the protobuf plugin in Goland is that it makes it so go to definition for the Go struct for a particular protobuf message jumps you to the protobuf file, but then you can't do find usages inside of the protobuf file. Instead, it does find usages of the protobuf message and not the Go struct, which is always what I actually want. So that's always pretty annoying. But I don't know what to say about that. It just is what it is. So here's the struct, and now we can look at usages of it. Yeah, exactly. Lazy calling of nodes when required instead of always calling them. Exactly. So that would be really nice if we could set that up, but it's, I think, quite challenging to get the various concurrency bits in place such that it works. But it really would be good. Let's see here. Okay, so here's our setup flow request, and I think what happens when we call setup flow on the client side, where is that done? I want to see where that is done. Let's see. Struct initialization. Okay, so here it is. Setup flows. Set up all the flows specified in flows using the provided state. It will first attempt to set up all remote flows using the DSP workers if available. Sequentially, if not, then finally set up the gateway flow. So when we run these setup requests, what actually really happens? Run a request. We dial a node, we make a client, we run setup flow, and then there's a resp. And the resp, what I don't understand is what do we set up on the client side when we make one of these flows, right? There's a bunch of stuff that happens, and I'm searching for that. Runner result. Now we wait for all the flows to be scheduled. Note that we are not waiting for the flows themselves to complete. We wait. Then we say, set up the flow net. But where do we like register the fact that these remote ones actually exist? That's what I don't really get that. Unless that happens on the remote side also. I really don't know how this stuff works, actually. I know there's something called a, let's see, what is it called? What am I thinking of here? There's basically this thing that happens where we wait. We set up a flow and we wait until the remote side is connected to us. And if it fails, it times out and then the whole thing turns off. And I'm trying to remember the name of that error. So if I remember the name of that error, then I definitely will be able to find the code that runs it. But I'm having trouble remembering the name of that error. It's like timed out. Maybe I can just look and set up flow. So this is what happens on the remote side when we get one of these RPCs. At some point we have to like do a bunch of work, right? So blah, blah, blah. Set up flow. So this guy, right? Most of the files are really long. Yeah, we definitely have a problem in the code base with giant files. But I don't know. I think there's certain packages that are well structured and certain packages that are not well structured. And yeah, long files, man. It can be annoying. It can be hard. Giant files are a Go thing. I think it can be hard to know when to split up a file, especially if like the file already exists. Like nobody really wants to be that person necessarily. It's also like, I feel like it's pretty common to want to put all the methods for a particular struct in the same file. And if you have a big implementation, that can make a giant file. Is CouchDB an open source company? So I work on CockroachDB, which is different from CouchDB. But we monetize it by, we have sort of it's open source, but there's enterprise features. So we sell licenses for enterprise features, and we also have a cloud product that you can buy. Like, basically ask us to, what the heck is this? A weird Eleanor Rigby cover. You can ask us to host CockroachDB for you, or you can run serverless CockroachDB via Cockroach Cloud. Small files are actually a Go thing. I'm sure they can get big, but find longer files, generally speaking, elsewhere. I feel like it might depend on the thing that you're working on. So do you think it's this? Schedule flow? Queuing flow to be run later. Where is the thing where we wait? Don't know where that darn thing is. Yeah, I think Go does make it pretty easy to factor your code well, or at least in terms of splitting up packages and files, just because there isn't that much to do that. I think the harder thing, like it gets out of the way. The mechanics are not in the way. The harder thing is, as always, you know, figuring out for yourself what those package boundaries should be. That's definitely the thing that's the hardest. But that's true in every language. Okay, I'm really sick of this playlist. I'm gonna switch it to something else. The human factor is always the hardest, right? Is there like a wait for flows or something? Wait for flow locked? Yeah, this is definitely it. Okay, so wait for flow locked, waits until the flow with the given ID gets registered up to the given timeout and returns the flow entry. If it elapses, return nil. Only be called by calling the mutex. So where does this get called? Connect inbound stream. Yes, this is the thing that I'm looking for. Where do we call connect inbound stream? Flow stream int. Flow stream. What is flow stream? Flow stream. Flow stream. I don't really see who calls this thing. Flow stream server. Flow stream is used to push a stream of messages that is part of a flow. The first message will have a stream header which identifies the flow and the stream. The response is a stream that the consumer uses to perform a handshake. Interesting. I mean, part of me feels like, why can't this be lazy then? If the waiting actually happens at this level. I guess it could get really complicated if you have a much more complex graph. Like imagine trying to teach this guy that it might be getting data from a node that it doesn't know about yet, right? Like what happens when we do new unordered? Like who sets this thing up? So this unordered synchronizer is basically this blue box here that needs to listen to all of the remote nodes that could possibly be talking to it. I'm trying to wonder whether it has to know statically ahead of time. Yeah, it kind of does, right? It has these input stream ops. And it has exactly the number. So... makes a new inbox. But a new inbox might not necessarily have to like wait for any actual work to get done though. Is that right? I actually don't know. This just does some initialization and doesn't actually wait for any data. Add stream endpoint. Stores information about an inbound stream. Add remote stream. So this just sets something up. And the stream info is what? It's got an inbound stream handler. Connected, yes or no. Canceled, yes or no. So what is connected about though? Oh, this is this connect inbound stream thing again. Interesting. Okay, so let me think. But the only thing is that we're only calling this once. we actually push data to it? I don't really get that. The heck is all this? So we call flow stream from the out box. Does that make sense? What does that mean exactly? So we call flow stream when we run an out box. Okay, so in this case, what we're doing is this outbox calls flow stream once. And when is this moment that we're calling this? When we're calling run. I see. So basically we only call flow stream once we have an outbox and we're going to set it up. So theoretically we could defer calling this run thing until later. I don't know. This seems really kind of hard, to be honest. Run starts an outbox by connecting to the provided node and pushing batches over the stream. After sending a header with the provided flow and stream ID, set up remote output stream. And this is done. This is done at flow setup time on every node. So it's kind of like we talk to every node. We tell them all to set up their outputs. Their outputs talk to their further downstream outputs. And that kind of triggers this cascade where as soon as we call flow stream, then they're also expecting to hear back from all of their inputs at some point. So it's kind of like it all happens at once and doesn't seem easy to make it dynamic. What's up, half a Momo? How's it going? We're just kind of chilling. We're thinking about ways to do stuff, but I don't know how well it's going. We were doing pretty good, and then we started speculating about doing something fancy, and I'm getting discouraged. How are you doing? What are you up to? How did you find the stream? I'm curious. Were you browsing science and technology? I'm always curious how people stumble across this thing. Maybe we have to just leave this particular project as is for now and move to something else. I don't know. What do you guys think? What should we do? I think we basically want to wait until this thing tells us if it passed tests or not. And then at that point, We should fix any other broken tests. And then, you know, what we could do is we could think about a heuristic for it, maybe. We could think about a heuristic for it that we could do without the cost-based optimizer, maybe. How could we, what would be a good heuristic for using this thing, right? It's like do it if the cardinality is high. And maybe we could mix in some kind of estimate of the histogram or something like that. I don't know. Book article or something. So I have this DB books thing, but I think this DB books is mostly about how databases are built. I really like, there's something called use the index loop. Have you seen this? This thing is pretty good for learning to structure your database. Take a look at that. I'm going to take a very quick bathroom break, you guys. I'll be right back. Hey guys, I'm back. Hope you've been chilling, listening to this beautiful music. It's so relaxing. It's a lot more relaxing than synthwave. I think synthwave is a little bit too intense for this stream, honestly. I don't think I'm into it. But yeah, I don't know. I feel like this thing, it's either done for now, or it's like too bad to merge, or we need to come up with a heuristic. I don't really know. I really don't know, actually. I think this dynamic thing is much too complicated. I don't think that we can get it done. I think that I feel like the thing about the heuristic that's confusing is that we currently have this philosophy where it's everything or nothing. It's like either we distribute something to every node that could have data for it, and we do this both for regular scans and for this new join reader policy, or we do it to just the current node that the thing is on. And we never have an intermediate ground where we just pick some of the nodes or some number of the nodes, right? And the reason that we don't do that is because we're afraid to make like a guess at how parallel we want to go, you know? It's go. It's go, AWS Dynamo. But yeah, we don't have a policy about like, we want this thing to be, you know, 10x parallel. Looks like TypeScript combined with C. I guess so. I guess it just looks like Go to me, but I've been programming in Go for too long at this point, I guess. But yeah, it's hard to imagine what the right policy really would be if it's not everything or nothing, right? Like, you wouldn't want to say, I'm just going to pick 5 out of the 10 nodes that data could possibly live on, because just why? It's almost like a law. It's like a magic constant law. You know, people don't want to pick something that's so arbitrary that it can't be explained, even if it might be better, because how could you explain what that choice is about, right? So I don't know. I mean, let's take a look actually at to SQL Physical Planner. There is some heuristic that's used to do the initial table reader thing, right? Plan for scan. Init table reader spec. Create table readers, right? One for each node that is spans where you're reading. I guess I would say follow your heart. Is there one that seems more exciting to you? I think that if you can follow what is exciting to you, you're going to be happier and probably learn more in the end than if you follow something that you're just doing to chase career. I think you really want to find something that excites you, ideally, if you can possibly help it. I think that both of those skills are extremely universal. Deployment, DevOps, Docker, Kubernetes, extremely universal. Database is extremely universal. So it's tough. I think that maybe if you're doing a lot of application development, maybe I would have a slight preference for learning about databases, because DevOps is kind of a different world a little bit. And databases are sort of you always have to know about databases to use an application or to write an application. So maybe slight edge for databases, but I'm not really sure. So basically the way it works now is that if there's no limit on the query, we plan all table readers where their data live. So we distribute everything unless there's a limit or unless something else. What is this? Is local? Is local set to true for planning this query in a single node? And we only set this for like weird exceptional circumstances, I think. Right? Or do we? Actually, I think we might set this in other cases. Like we might do, yeah, there's this recommendation thing, right? Should distribute given rec and mode. And where do we get this recommendation from again? Yeah, I work for Cockroach Labs, which is the company that makes CockroachDB. Have you guys started to go to the office or still remote? Still remote, but that's hopefully going to change soon-ish. I think some people are eager to go back. I'm not so eager to go back, honestly. I have a really comfortable at-home setup, and I don't miss commuting, but, you know. So... construct scan. Oh, this is the new spec factory though. Where is the old? Is local. Do we only set this thing in that weird way in the new factory? Oh yeah, so this is just for dis-equal spec exec factory. This is like the next level code that's going to eventually enable us to make physical planning decisions in the cost-based optimizer, but we're not there yet. It looks like we mainly do it here. And so in this case, we say distribute equals distribute and for system tenant. And when do we say distribute here? New planning context. Distribute plan.will distribute. What is this? Get plan distribution. Okay, what is this? Returns a plan distribution that the plan will have. So I think this is, oh, should distribute given record mode. Where's the thing where we iterate over the plan, searching if we want to do stuff or not? Or is that just done the... Don't really get this, honestly. Consistent hashing. So CockroachDB doesn't use... Consistent hashing is used for databases that don't have range scans as a requirement. So it's sort of for a hash partitioning scheme instead of a range partitioning scheme. So CockroachDB uses a sortable key value map at the bottom layer. SQL is built on top of that. And you kind of need a sortable storage scheme for SQL, since SQL is really based on ordering and range scans. So we don't use a consistent hashing model for CockroachDB. You can make indexes in Cockroach that are hash partitioned, but we don't support any kind of consistent hashed method for that. There's sort of reasons why it's tricky. So we stick to sort of a static hashing scheme for that. So this is by, if you want to say like, I want an index that is sorted, but also kind of partitioned by hash. For that, you kind of need a static number for various reasons. But it's not really even common that you need to use a hash partitioned index in Cockroach. Most of the time, you just don't need to think about that at all. So there's a long answer, but basically we don't have consistent hashing, but we don't really need it, since we're all about ranges and range scans. Get plan distribution. I'm still a bit confused, to be honest. I'm glad you like it, Plexical. Love to hear stuff like that. Are you using it for something? So a database server stores a range of keys. If I add or remove server, will I just... Okay, so yeah, there isn't like a notion of next server really in Cockroach, since I know you're probably thinking of that picture with consistent hashing where there's like a circle of the nodes all sitting next to each other, and in consistent hashing, there is like a next node where they'll sort of inherit the range that got deleted. So in Cockroach, by default, the nodes are sort of uniform in the sense that there's no reason why a particular node would be more likely to get picked to own part of a range or not. So let's say we have a replication factor of 3, which is the default, and we have 9 nodes or something like that. It means that every range gets distributed to 3 nodes. And how do you pick those 3 nodes, right? That's what this is all about. What's the placement policy? And by default, there is no placement policy that is different from just randomness. There's a few things that come into play, though. Load-based rebalancing is a thing. So if you start asking a particular node a lot for data from a particular range, over time, a replica of that range will be transferred to that particular node. In addition, there's things like zone configurations, which is a word that we use to mean configuring your nodes based on data center, rack, region kind of thing, like you have in Cassandra also. And you can set up zone configs so that tables are replicated in a particular way. Like let's say you want, some replicas of a particular table in this data center and some in that data center, then you can sort of set up these constraints, and the system will solve the constraints and place the data replicas where you want them, spread them out evenly or bias them to a certain spot or whatever it is that you want. So, yeah, it's similar in a way to what Cassandra does for stuff like that. I don't know how HDFS really works, but maybe it has something similar. Plexical says, evaluating now, hasn't been anything negative. Playing with this weekend, starting a large company, chat offline at some point. Oh, that's awesome. Yeah. Well, if you need any contacts for folks, happy to connect you. Although it sounds like you're probably connected to folks already, but anything like that, yeah, you can DM me on Twitter or send me an email. It's jordan@cockroachlabs.com. Can help with that. But that's awesome. That's awesome. Hope it goes well. Does streaming affect my productivity? Yeah, definitely. If I streamed and tried to be productive, that would not really go well. So I do this on Fridays, sort of for, it's a combination of fun and DevRel and making sure that I can stay connected to the code of Cockroach. My job is not really, it is an IC programmer. I'm a director of engineering, so I do more management than coding by like a very large factor. And so this thing on Fridays is sort of just for me to have fun, stay connected, spread the word, chat with people about databases and stuff like that. So it's kind of like a hobby, personal / professional thing that I do on Fridays. Not trying to be particularly productive during this time. Maybe a little bit, but not too much. Don't smoke weed and code. Not good. Yeah, I don't think that would work so well for me. Okay, so I still have no idea what's going on here. I'm basically trying to figure out what is the heuristic that we use for when to distribute these table readers or not. So before this change, the table readers were the things that caused any distribution to happen or not, right? It's like coming back to our diagram over here. If you're reading from a table and it lives on these 3 nodes, then we spread it to these 3 nodes. We spread the computation to these 3 nodes. And if it only lived on 1 node, we would only spread the computation to that 1 node. The thing that we've added is you can also choose nodes based on the value of this join reader thing. Like if you're doing a lookup join to a table that lives on some other node, then you're going to include that in the distributed plan. The thing that I'm trying to find out is which conditions do we choose for distributing this table reader phase at all, and whether there's some analog that I can make for the join reader case. And I don't really know. I'm trying to find that out. Always happy to answer questions, and I'll try to be as patient as possible. But I think I'm a pretty patient guy. I like answering questions, even if they're totally, basic or random or anything. I like that. Part of why I like the stream so much is because random people will come and ask things, and it'll take it into different directions or whatever. So ask away. Okay, so the thing that I'm most confused about is this is local flagged because I can't tell when it's set, but I guess I'll just ignore it. I guess I'll just ignore this. The only other condition though is if we have no hard limit, and if we have no hard limit, then we spread it everywhere. If we do have a hard limit, then we use a single table reader. But what about the case that I definitely know exists where there isn't a hard limit, but we don't distribute? That's what I don't get. Like, for example, let's take an example here. So we're going to say cdemo nodes equals 3. We're going to say create table a int primary key, insert into A, select G, select star from generate series 1 through 10,000. And then we're going to say alter table A split at values 3,000, 6,000, 9,000. And then we'll say alter table scatter. Okay, so now we have a little alter table A scatter. So now we have a little table that's distributed around. And if I were to say select star from A, where A is equal to 10. And now we're going to run explain to SQL on this thing. This thing does not get distributed, even if this thing lives on some other node. Even if this thing lives on some other node, we don't distribute this plan. And I don't understand where that's coming from. You see how it says distribution local? Like where is that coming from? I want to answer as patiently and clearly as you in my interviews. That's tough, honestly. I don't think that I could be so patient and calm in an interview setting either, because it's very high stress. That's part of the problem with interviews in general, is that they're extremely stressful. They're high stakes. You're nervous. It's a stranger. You're trying to impress people. That's tough, man. I don't know what to say. I don't think that I know. I think, you know, the more experience that you get in your career and the more confidence that you have doing tech stuff, maybe it helps a little bit. I think it is all about confidence, but I do think that that's really tough. Do you do practice interviews? Have you tried to practice with a friend? I think that can sometimes help. Sometimes even if it's not a friend, if it's actually somebody that you like kind of know, like a former colleague who is offering to do you a favor, then it's like a little bit stressful, but not as stressful as like the real thing. Practicing and filming yourself, that's a good idea. Yeah, wrote answers. That's true. I feel like what's so hard about the tech interviews is that they really force you to think on your feet, and it's hard to prepare for that, because you can panic if you get scared. Yeah, you black out during an interview. I feel the same way. Follow-up questions. Yeah. Yeah, you can memorize the frameworks. That's definitely true. Yeah, you can study, you can think about strategies, plans, and lay out your plan up front so that you can kind of hook into something that you remember, even if it's a question that you don't understand. But it's always going to be stressful no matter what you do, because you might not know the answer, right? So yeah, part of what you're saying, AWS, is that you want to be able to answer as patiently as clearly in an interview setting as I did. But the thing is that you asked me a question that I like very well know the answer to, because I've been working on this database for like 5 years, and I've been thinking about databases and whatnot for like that time. And I do this stream every week, and I'm very used to it. So it's like extremely in my comfort zone. And the whole point of interviews is that they're often, very often, out of your comfort zone. So it's a bit apples and oranges, I think. Maybe it's under check support for plan node. Maybe it's this check support thing. Ooh, yeah. Yeah, this is it here. Okay, so for example, let's say I used Kafka before. I know the basics. Sure, I used Kafka Spark in my last job, but we just study whatever is needed. We don't go too deep as software engineers. We just follow the managers thinks best. That is very tough. So this is a very common thing that I see actually in interviews. So I do a lot of these like design interviews where I'll ask somebody about something that they built at their last job or a system that they were working on in particular. So not like a little algorithm, but like, you know, tell me about the project that you worked on last. And I'll try to interrogate them and ask them all sorts of like questions about the choices that were made and why things were done this way, or what are the trade-offs that were done and stuff like that. So just try to get a sense for how people are thinking about a systems-y problem, a trade-offs and choices-y problem. And a very common thing that I see is that people will have been working at a bigger company where they don't know why something was done that way. And they just sort of say, well, that's just what we have, right? And it's very tough because that isn't like, it doesn't seem good, right? It doesn't present well when you hear that, because you really want people to be introspective and give their opinions about why something was done a certain way or what some different alternatives could be. Because what you really want to see is when this person joins your company, will they be applying the right kind of critical thinking to big choices? The thing is that a lot of the times, like, people didn't have the space to make those choices at their job. So it can be tough. That being said, I feel like you can get around this very easily by knowing ahead of time that people are going to ask you why something was done a certain way, or what are the trade-offs, what are the alternatives. And I think what you can do to prepare for that stuff is try to blank your mind of the fact that you inherited the system and think about it from a higher level. Like, think about, okay, yes, we used Kafka, but what's the purpose of Kafka in this system? Like, what are the messages that it's listening to? What is the load that it's soaking up? What would happen if we didn't have Kafka? And just try to think about, you don't even have to like have been in that decision, right? You just have to be like, well, the reason that we have Kafka is that, you know, we needed to make sure that the system that was listening to Kafka, if it crashed halfway through some processing, it's always going to receive all of the messages at some point, right? You can talk about that. Like an architectural principle, the idea with Kafka is like, it soaks up things so that there's some more fault tolerance in the system, right? Or there's some scaling. If there's a burst of traffic, you can still process it. You know, things like that, like a higher level, just thoughts and ideas about what the purpose of such a queue is in a system. And if you haven't studied this stuff in your career yet, that's totally fair too, by the way. And I would say, like, for our process that we use at Cockroach, it's very much weighted by like, well, is it reasonable to expect that this person in their career so far will have thought about some of these higher level things? And, you know, it's like, you know, I think if you're a younger person in your career, haven't done as much, then typically we expect that those people will do better on algorithms than some of these higher level systems thinking things. And it's sort of vice versa in the other direction. But I don't know. I mean, every company does it differently. And interviewing is really horrible for everybody. It's bad for employees. It's bad for employers, because everybody knows that it's not perfect, right? Like, even the people who are giving those unfair interviews, they also know that they're unfair. And it's very hard to know what the right way of doing an interview is. So basically it's depressing and I don't know what to say. But keep studying and keep practicing. And I think you'll find a way to find a position that's good for you. It's DB Books. I should add an alias for just books, I guess. What's up, Cyanide and Hermit, by the way? So what's happening here is that it's a very simple heuristic. If it's locality optimized, we say we can't distribute. If it's a full scan, we say we should distribute. And if it's not, we say we can distribute, but there isn't a should. And so I think what this means is that we only distribute plans if they have a full table scan anywhere in them, which seems kind of crazy, but maybe that is what it is. Compose returns a recommendation for a plan given recommendations for two parts of it. If we should not distribute, and we should not distribute the overall plan either. So cannot equals cannot. Should not equals should not. Should or should equals should. Okay, so if we see a should, we distribute things. So I guess it means that even if we don't have a full table scan and we do have a aggregation, we distribute everything? Is that what that means? A little bit mysterious. A lot of stalling techniques you can use. Techniques for turning a question around. Memorizing you can do to improve the odds in your favor. Yeah, I think that's definitely true. Definitely true. And yeah, I think like another thing is I feel like any question, you can kind of take it and if you don't know exactly the answer to the question they're asking, try to like customize it to something that you do know about, right? Especially in these more talky interviews, it's very infrequent that somebody's going to be like, no, tell me exactly the answer to just the thing that I asked, right? People often don't say that sort of thing. They kind of just want to get you talking about something that you know about and kind of show off how good you are. Because ultimately, you are good. And people want to see that you are good. So make sure that they see that, even if it isn't perfectly answering the question that they've asked with the words that they've used. Making a joke about being stressed out and it makes the person relax a little bit about it. Yeah, that's true. Yeah, establish some rapport, right? Establishing rapport with that interviewer, it's always a helpful thing. Databases are complicated. I wonder how the implementation starts. One of my colleagues actually has something called ToyDB. Let me send it to you. So this guy, Eric, he made a distributed SQL database in Rust as a learning project, which is pretty impressive, honestly. Most components are built from scratch, including a RAF-based distributed consensus engine, an ACID-compliant transaction engine, pluggable storage engine, iterator-based query engine, SQL interface. Like, wow, the heck, this is crazy. I've never even looked into this thing, but it's very impressive to do all this yourself. So, Eric, smart guy. Not sure if Eric's dropped by the stream, but if he does, I'll let you guys know. Introduce him. But yeah, I don't know. Maybe you could check this out if you're interested to see what it's like. The other thing is that, yeah, in this DB books thing, this CockroachDB guy, CockroachDB is all about making a toy database. And you can see kind of starting it from scratch. But it's like, so let me actually do something. I'm curious. So let's say I have show ranges from table A. So it looks like value 9,000. So if I were to say select star from A, where A is equal to 9,500, and do explain to SQL on this thing is going to say it's local, but the data actually lives on node 3, right? So I think if I were to say set to SQL equals always or something, and then run it again, then it's going to distribute it for me, right? Yeah, so now it distributes this thing. The question I have is, in this compose recommendations thing, it's seeming to say, if I have a group node, then I should distribute them. So I'm wondering if I were to say, let's turn this to SQL equals auto. So this is what it usually is. If I were to say something like select sum of A, or is this not really going to work as a, no, I think it does. So it says group scalar scan. So then if I do this, will it actually does distribute that. Isn't that weird? I feel like that's actually kind of a little bit odd, maybe. Is this odd? Is this unexpected? It's kind of weird, right? It's just, it feels so rudimentary, this little heuristic algorithm. In fact, it's so rudimentary that I'm very tempted to file an issue about this because this just feels so wrong to me. I'm gonna make an issue just so we can at least find a way to have this conversation with people. So here's what we're going to say. We're going to say SQL distribution recommendations are too aggressive. in some cases. So let's see. The dist-SQL distribution heuristic is very simple. If a particular plan node is marked as should distribute, and no other plan nodes are marked as should not distribute or cannot distribute. Is that what they're called? Cannot, should not. The plan will be distributed.
How's it going, man?
Only a few plan nodes are marked as should distribute. Aggregation, let's see, we'll make a little list. So aggregations are always marked as should distribute. Zigzag joins are always marked as should distribute. Is that it? I think there's more, right? So
Welcome to the program.
aggregations,
I thought the show was over.
inverted joins.
Yeah. Oh, yeah. Oh, okay.
Inverted joins are marked as should distribute if their expressions are supported. Hash joins are marked as should distribute. Full scans are. Full scans are marked as should distribute. Let's actually, hold on. I have another idea here. So let me go back to our demo. Let's recreate it. Let's add a little bit more color to it. So we're going to make a table that has two columns, one that's indexed and one that's not. We're going to insert G plus 1, G of G, split, scatter. Okay, so then if we say something like select star from A, select star from A where A is equal to 1000 order by B. What do we get here? We get distribution local. I think that's because the order goes away because there's no, I think what we need is A less than 1000, A greater than 1000, and A is less than 1002. Okay, even this one doesn't get distributed. Why is that? Order by B. Why doesn't this? Oh, it's because I need to have a range of more than 0. There we go. Okay, so now we have, yeah, so we get full distribution for this case, even though there's really no reason to do it. Okay, so let's go back to our issue. Full scans are marked as should distribute. Sorts, non-limited sorts are marked as should distribute. Is that it? I think that's going to be it at this point. So should distribute. Also zigzag joins, which we already have. So let's reorder these to make more sense. Aggregation, inverted, hash, full scans, non-limited sorts. Let's actually pull full scans to the top because it's the most obvious. The hash join you just mentioned, does it involve making a hash map from one operator and then compare it with every element from another operator? Is that how it works? Yes, that's exactly how it works. So a hash join, it creates a hash table out of one of the sides of the join, and then it streams the other side of the join, searching for matches on each side. It's pretty simple conceptually. There's a lot of things that it does under the hood that are more complex. Like if the hash table is too big to fit in memory, various things have to happen that are tricky, but fundamentally, yes, one of the sides is consumed completely and created and put into some sort of hash table. Okay. So only a few plan nodes or markers should distribute. So let's see. Because of the simplicity of the heuristic, certain very simple and low cardinality plans are distributed when it feels like they should not be. For example, even a point query that is immediately aggregated, by the way, well, let's get rid of that. I feel like there's a separate issue that we should file. For example, even a point query that is immediately aggregated, point query that reads just 1 or 2 rows that is followed by an aggregator will be distributed, even though the aggregator is extremely cheap, since only even though the query, I don't know, how do I say this? Even though the query is no more efficient than if it were planned locally, since the cardinality is so small. Let's paste this example here. So the example is basically all of this, but we'll delete a bunch of it. Yeah, so this is going to be good. So in this example, the point query without an aggregation is, of course, not distributed. But the point query with an aggregation is creating this simple plan. So if I were to ask you why I should use Cockroach instead of Postgres, what would you say? Well, it really depends on your use case. But yeah, I would definitely focus on the distributed part. I would also say that Postgres, it depends on like how you want to deploy the database. If you want to run it yourself, Postgres, you know, it's a pretty good thing. It's a very good database, and I have no ill will towards Postgres. I think it's an excellent product in many, many ways. Cockroach Cloud is a really, really good way to get started with CockroachDB. We also have a free forever tier if you wanted to play with it like that. So we kind of have like a, serverless product that we're working on that will be a metered pay-as-you-go billing thing. But in terms of why we should use Cockroach in general instead of Postgres, yeah, it's really all about a database that can scale horizontally in a way that Postgres really can't. You can have read replicas in Postgres, but they're just for reads. They're not for writes. They're delayed. There's consistency problems with that. CockroachDB allows you to have horizontal scalability of your Postgres like database without any real downsides. So that's kind of my answer there. Horizontal scalability. Okay, so I think that the distribution heuristic should take into account the fact that the cardinality is very low and not distribute in this case. This feels like something that the CBO, cost space optimizer, should help us with, not adding more logic to the heuristic distribution engine. Distribution algorithm. I guess I'll just make this dist_SQL colon. Okay. The other thing that I want to look into, just like on a very simple note, is like, why does this sum not get elided, considering the fact that we can infer that there's only one row in this case, right? Let me make a simple test case here. Create table A int primary key. Select sum of A from A, where A is equal to 10. This sum should go away, or rather this should use explain. This makes no sense. This group by should just be elided altogether, I think. This may not be an important optimization, but I'm kind of curious what people think about it. So we'll say opt one row. Oh, do we still need it though? Oh, we still need it because it could not find a match. And if it doesn't find a match, then I guess you need some sort of special condition. I guess you still need the group by. Okay, I won't file this issue because it makes no sense. Why should you not be distributed? Meaning, like, why should you use a non-distributed database? I would say basically complexity and cost. If you don't have requirements for availability that are high and you don't have need for horizontal scale, then you might not need to have a distributed database. But I think most applications these days, you really want to make sure that they're highly available and scalable. And so for that reason, I think these days there's pretty much no good reason to be running a single node database without some kind of replication. I think that's kind of table stakes for most web-like applications these days. But yeah. How much do I value lead code personally, or or in terms of like interview preparation? I think many companies really expect that you spend a lot of time doing lead code stuff, but I guess I don't know what to say. I think that knowing basics of algorithms is important, like understanding recursion, understanding dynamic programming, just like basics of algorithms, data structures. That stuff's definitely important. I think that whether or not somebody knows a really, really tricky one, I don't think it's as important. I don't know. I think if I definitely, when I can, try to make the interview questions that we ask feel more practical and solvable than tricky. In fact, there's a whole blog post about how we do interviewing at Cockroach. Maybe Cockroach Labs open source interview. We have some, I don't know, we have some blog posts about this. There's this thing, and then there's this exercise-based interviewing thing. So we've definitely like thought a bunch about this as at the company. I don't know. We still have like coding tests, but obviously, but like hopefully they're not as like trick oriented. I do feel like a lot of the stuff that people ask you to study lead code for, it's really all about like, can you figure out the trick for some particular thing on the fly? Like, you know, invert a binary tree or something like that is, you know, doing stuff like that. I think it does demonstrate competence, but I think it can also just be frazzling, and it isn't really the most practical kind of task in the world. I don't know. It's complicated. Okay, so it looks like I feel like inverting a binary tree is kind of like a meme at this point. Everybody is always referencing it as something that's a silly problem to solve. But I think it is a good example of something that might be a little silly. Oh shoot, I forgot to run make basil generate. You're not using basilisk. How do I get basilisk? This is new. Installing basil, use basilisk. I'll just use the go method. Oh crap, I don't want this. I think I want go install at latest basilisk. Okay, let's try this again. Make basil generate. You're not using basilisk. What do you mean you're not using basilisk? Oh, do I need to? I don't know how any of this stuff works. Ugh. Build systems, man. They're definitely tricky. Definitely tricky. Sudo, whoops. Oh gosh, what did I do? I lost all my windows. This is what happens when you try to do anything that isn't just typing in the IDE. Everything goes crazy. Okay, dpackage-l grep basil. Okay, so what if I say sudo apt-get remove basil? And then don't type my password on screen. And then I try again. Now what? Now it says basil not found. Okay. But what the heck am I supposed to do here? Okay. This adds both basilisk. Okay, maybe I just need to open a new terminal window then. What? I don't understand. I have no experience in CockroachDB, but it has something like Oracle that keeps history of what history table of what session is doing per second. Yeah, so definitely we have something like that. So if you look at, if you go to like the DB console and click the statements page, so this page is kind of this observability thing where you can sort what's being run by looking at all of the different statements that are run. You can try to see how long they took. You can try to see if they have any contention, how much memory they're using, and stuff like that. Per session, we do have a little bit of information. We have the sessions page that shows you information about what each session is doing, but we don't have a log of all of the things that a session has done because it's really expensive to persist that. But if that's something that comes up for you, I'm interested to hear about it because we don't write that down right now. Just because, yeah, it can be a lot of data to record, but maybe it could be useful. Really, we just have what's active in transactions and statements per session, but not the history. Wonder if we should add that. I think we just haven't because we think it's going to be expensive memory-wise to write all that stuff down. Should I just do ln sf go bin basilisk go bin basil? Does this work? Okay, that seems to have fixed things. Not sure how legit that is, but that is okay. Right. Okay, so did this change anything? This changed 2 files, and I think we modified them both in the last. Big help for troubling. Always use it when some comes that asks why something was slow for 15 minutes back in time. Yeah, we have history of what all the statements have been up to, in a sense. Like we have persistent statistics on the statements that we're adding in the upcoming version that's releasing this fall. Previous versions didn't have persistent; it was only in memory. But the persistent should help with this, but not the per session thing. That's a fair point. Yeah, I'll think about adding that though for sure. I think we have an issue for it actually, but we haven't gotten to it yet. So let's see. Git add 1.2, git commit amend, git push fmine. Yeah, so I don't know, guys. I feel like I might be running out of steam for tonight. I feel like we fixed this thing, we added a little feature, we talked a bunch, but I don't really have something that's lined up next. So I'm kind of feeling like I'm ready to wind down. So I think I'm gonna find somebody to raid. But this was a pretty good stream. Thank you guys for hanging out. Let's see. Science and technology. I'm trying to think if my friend, I think somebody that we wanted to raid last time, I think they were going to be streaming now. See if they're on. What was this guy's name? Hold on a sec. Bum 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 bum. Yeah, here we go. So let's see. Is he on? Adrian? Oh yeah, active session history. I've definitely looked quite a lot at active session history. So no worries there. Yeah, so let's go ahead and give this guy a raid. It's Adrian. He's actually going to be doing some work with CockroachDB, which is really neat. So I want to show him some support. So please, you guys, if you're there, I would like you to send him a bunch of emotes. So here's what you're going to say. You're going to go like this. You're going to say Twitch raid. Then you're going to say large D2 ancient, if you've got one of these. So kind of like this. So grab this thing, set it up in your paste buffer. Okay. And we're going to basically say raid it's Adrian. Yeah, there you go. You don't have the emote since you're not a subscriber, but that's okay. That will do just fine. But if anyone else is out there, get that stuff into your paste buffer and prepare yourself. Say hello. And yeah, just give this guy your support because I think he's a homie, and we wanna befriend him. All right. There you go. Okay, so that's that. Thanks again for hanging out, everybody. It's been a lot of fun. See you next Friday. Have a good weekend. Have a good week. Bye-bye.